So now we will take a look at switch statement in Java. So the switch statement. So till now we have seen the if and if else decision statements. So now we will see another one, that is switch. So by definition, the switch statement is an easy and convenient alternative for the if else ladder. So previously we have seen the if else ladder. In that if else if else if else if like that we had written many times. So when we have large programs and they are over a single value, so it can be problematic and tedious to write such if else ladders. So the switch is an easy alternative for that. So let's look into it. So now we will see the syntax of switch. So here we have the switch keyword. So this is the switch keyword. So we have to write the switch keyword first, then this opening parenthesis, then this expression here. So this expression must be a value, and then this closing parenthesis. So this expression here should be a constant value, and these values will be checked and these cases will be executed. So let's say here we have this expression is an int variable. Suppose this is an int variable with the value 4, and now we want these cases to execute. So this is case 1 and here value 1. So suppose the value of this expression is 4, then execute these statements. So if the value of this expression here is suppose say 4, then this here we will specify the value here. So case when the value is 4. So this case will be executed when the value here is 4. Then these the sequence of statements we have to execute, then this break keyword. So we'll get to this keyword now, and then the another case. So then case and then value 2. So suppose if the value of this variable for this expression is suppose 5, then for case 5 here the value would be 5 here. So case 5, execute this set of statements, and then there would be another break keyword, and then this would go on till n. So this can go on till n number of times, and then we write the default case. So if any of these values don't match, suppose I have these values from 4 to 7 and here the value results to be 0, then I don't have any case here which responds to 0. So in that case this is default. So if if the value of expression doesn't match any of these, then this default would be run. So we'll understand this in a program. So we had written a program for printing, taking input the number and printing its equivalent word in the if else ladder. So we will see the same program. So we will write the same program for same output using the switch statement. So let's see that. So here I have my int variable, and let's initialize its value to 4. So now I have to write the switch case statement for this. So first, as we have seen, the switch keyword. So the switch keyword, so this switch keyword, then this opening parenthesis, and now in here the value, the variable whose value we want to check. So here in this case we want to check the variable a. This variable a is what we want to check. So here I'll write a, and then now here this opening and closing parenthesis, and now in here we will write the cases. So suppose case when the value of a is 1. So this one here. So case when the value of the variable a is 1, and now here a colon, and now here we will write the statements which we want to be executed when the value is 1. So simply we want to print the word 1, O-N-E. So we will write the print statement here. So this one we will write here, and then we have seen the keyword break. So this keyword break will break the execution from here. So we will take a look at this keyword in a moment now, and then so now this is done. So suppose now I change this value to 1 here and I run this program, then we are getting this output 1 here. And similarly if I change the output to suppose 3, then we are getting no output because there is no case when the value is 3. So let's write this for all of our cases. So case when the value is 2. So here case when the value is 2, and we simply want to print the word 2 and then the break. So whenever we write a switch case, so this switch and then in the variable in parentheses and then the case, then this value and then this colon is important, don't forget that, and then the break. So these are constant, so these remain the same. This is the syntax, and whatever we want to write, we will write a statements here. So it is necessary to memorize this, because if this colon is missed or anything here is missed, then we would get straightforward error. So I'll just copy paste the complete program. You can type it out. So there are multiple cases. So till 9 we are checking the cases. So here the case when the value is 1, so we are printing 1. Then similarly when the value is 2, we are printing 2, and this goes on till 9. So from 1 to 9 the values will be printed. So now let me run this program, and here we are getting 3 as our output. So what happens here is the value of this variable a is 3. So when this switch statement is encountered, the executor or our machine or our computer will understand that we want to check the values of a. So it will go in linear order from top to down. It will go on checking the values. So here it will check if the value of this variable a is equal to this value specified here, the values we have specified here. So if the value is equal to 1, then it will execute these statements here. If the value is not equal to 1, then it will move on to another case, then it will check this value. So since this is also not equal to 3, then it won't execute these and it would move on. So here this case is for 3, so here the value we have specified is 3. So 3 and the value of the variable a is also 3, then it will execute the statements here. So here we have written only one statement, so we can write n number of statements here, it doesn't matter. So even if I write another print statement and just print high here and run this, so we are seeing that we are getting this output. So we can run n number of statements here, it doesn't matter at all. And similarly it will go on till end. So now from the values 1 to 9 we can check any values, but let's suppose the value of the variable a is 0, and now I run this, then I'm not getting any output, because none of these cases specify what to do when the value is 0. So similarly, so what we can do here is we can make a case for 0 as well. So case for 0, and then we'll just print here 0 and then this break here. So if we run this code now, then we will get 0 as our output. But now this was one case, here was 0. Suppose now if I have here value 15 and then I run this code, then again we are not getting any output. So we want the output, let's say in the range from 1 to 9, and then for any other number we want some default message to be printed if the number here, the value of this variable a is different. So how can we do that? Because we cannot add here case for every number. So for any other number there should be some default case that will be executed if none of these cases are matched. So that's why we have a default case here. So the default case, its syntax is the default keyword, then a colon, and then whatever we want to do. So we can say here invalid number, and then if I run this now, then we are getting invalid number as our output. So it doesn't matter now what this value of a here is. If this value is between 1 to 9 or 0 to 9, we will get the equivalent word here. But if the value is anything else, then we will get invalid number as our output. So this is what happens in a switch statement. So compared to the if else ladder, this seems convenient doing this. Here this is the same program here, this case and then this break. So now let's see some more. So here this case, it is necessary to write this word keyword case. If we just directly give the value and then try to run it, then we will get error. So this case keyword is compulsory. Similarly, this break, so the function of this break keyword is to break or stop the execution of this switch statement at that point. So whenever this break keyword is encountered, our program will get out of this switch case loop, this block. So let me elaborate a bit more. So suppose this is our switch case block. So now here what usually happens is, here if we have given the value 0 here and we run this, then we are getting 0 here, because what happens is the control comes here, it sees that this value is 0, then it encounters this switch. So now it knows that it has to check the value of the variable a and find a suitable case. So it will come here, it will find that this case is for the number 0, which is same as the value of this variable. Then it will execute the necessary specified statements, then it will encounter this break. So what this break tells the control is, now this execution of this switch or the work this switch had to do is completed. You can break out of it. So it will break out. So from here it will go forward and execute any other statement that is written here. So we have here another statement of printing here high. Then after this break, directly it would come here and this would be executed, and these rest won't be executed. So this is the work of this break. So if we remove this break, then try to guess that whether we will get an error or we will get some output. So if we run this, then we are getting here 0, 1 and high. So 0, this 0 here is printed, then this 1 here is also printed, but the value of the variable a is 0 here. As you can see, the value of the variable a here is 0, but we are getting here 1 also and then high. So this high is another part, this isn't included inside the switch block, so its execution doesn't matter here, but here inside the switch block this case for 1 is also getting executed. So why does this happen? So this is something known as fall through in switch statements. So we'll see that in just a moment, but it is necessary to note that without this break, all of the further statements written here will also be executed. The default case is not executed, but if we had any more cases here, then they all would be executed. So that is the significance of break. It tells to break out, so whatever block it is running. So this is the block of this switch statement. So here it will tell the control that break out of this block and continue on. So here after this break is encountered, it won't bother executing or checking these remaining cases. It will just jump out and do whatever it has to do further on. And similarly, here this default case, as you can see, it is written at the end of all of our cases. Here we have written all the necessary cases we had to check, and then we have written the default case. But if we remove this default case from here, and suppose if I put it here and then I give this, so let this value be 0 here, and if I run this, then we are getting 0 as our output. But now if I change this to 1 and run this, then we are getting 1 also as our output. So this default, here can be written anywhere amongst the cases. We can also write it here as the first one, and now when we run this, we are still getting 1 as our output, but it is not recommended writing default at the start or in between. As a good programming practice, default should always be at the end of all cases. And similarly, you might have noticed that there is no break keyword here. We have written break keyword after these cases, but after default there is no break keyword. So the break keyword here is optional. But what happens here is, now that here this break keyword is not present, and now if I change this to value to any invalid number in a case, and when I run this, then we are getting invalid number and 0 also as our output. Because what happens is whenever a case is matched, all of the further statements will be executed blindly. It won't matter that the statement here is a case statement. All of the remaining statements after this matching case are executed blindly. So what happens is this is executed, this statement for printing this invalid number is executed, then this case 0, this is ignored, and then this also is executed, so we get 0. Then this break is encountered. So what this break indicates is that get out of this switch block and don't execute anything further. So it will break out and we won't get this one output here. So this invalid number is executed because it is the default case, because there is no matching case for the number 12. Then this print statement is executed because no break is encountered, and then after this 0 is printed, a break is encountered. So it is getting out and carrying on. So if I just remove this break and run a program, then here we are getting this, all of these three are printed. So invalid number is 0 and 1. So having break for default is optional. So if I write here break and then I run this, then I'll get invalid number as a correct output. But as I said, as a default programming practice, it is recommended to write a default case at the end of all cases. So this is the same program we just saw for printing equivalent word for the number given. So here note that the switch keyword, then this expression here. So this expression and then this case, and here the value, whatever value we have to give. And also note that the values should be of matching type. So suppose here if this is of type, so this is of type int, and here I am giving suppose a char value, and if I execute this, then I'm not getting any error, but thinking logically this is wrong. So even if the default case is at the end and I run this, so I'm not getting any error. But we should not give here character values. This should be of the same data type as this number. But now you are also considering that we have used a char here. So since char, these characters are mapped as numbers. So if you want to check that, then in special conditions we can do that. But as a good programming practice, it is recommended that these data types here and the data types of these cases should match and should not be different. So if we give here suppose a string, now we are giving here a string and I run this, then we are getting an error that cannot convert from string to int. So here other data types are not allowed. The chars case was special case because the characters are mapped into integer numbers and are stored. So char is allowed here, but as you can see we have taken a string value, so this string isn't allowed, so we are getting a compile time error. So note that this data types of this, the expression being checked here and the type of data we are specifying here in the case should both match. So that was one more point, and then this is the same code here. Now moving on, we will now see use cases. So different use cases while using switch statement. So every statement inside switch must under be some case or default case. Independent statements are not allowed. So every statement inside switch. So here all of these statements, these are statements to be executed. These should under be some case. So this should under be some case or default. Either we should specify some case or we should specify them inside the default case. If we simply write statements, then we will get error. So here inside this, if I am just simply writing here, If I'm just simply printing this I here, and when I run this, then I'm getting error here. So we should always include whatever statements that are written here inside case. So suppose if I write here any case for, let's suppose case for 2, and then this would work. If I run this, then are not getting any output because the number here isn't 2. But if I just change this to 2 and I run this, so this case is mapped and we are getting a proper output. But if this is removed, then we'll get error. And if not a case, then it should at least be under the default case. Where default. So since no value is matched, no, there is no case for this number 2. The default is executed and we are getting I as our output. So every statement inside switch must under be some case or default. Independent statements are not allowed. I hope that is clear. Now this is the same example where if we run this, then we will get error in our output. Now the second use case is every case label should be compile time constant, otherwise we will get compile time error. I will repeat, every case label. Case label is the value which we write after writing the case keyword. So when we write the case keyword and whatever value we give here, so suppose we give the value here 5, so this value should be compile time constant. So what do compile time constant means? A constant value that we have hard coded in a program. So let's see this with an example here. So for better understanding, I'll just rewrite this. So suppose this we have here two variables now, int a and int b. So the value of int a is 6 and the value of int b, this variable b is 6 and a is 2. And now I'm writing a switch for the variable a. So as per syntax here, the switch keyword, then the opening parenthesis, then the value or the variable which we want to check. So the variable, then this parenthesis, this curly braces for the block, and then the case. So suppose here I'm giving case for the value 2 and I'm just printing here 2. So if I run this, then I'm getting 2 as our output. So this is correct. There is no error in that. Just one thing, that the break here is not written. So whatever statements, we won't get any compile time error, but the statements after this, if there are any cases, then that would be executed too. And then here, suppose now if I want to check for the value of 6, so here I have to write the value directly 6. I cannot write here b. So suppose if I write here case and b, and this b is a variable. The break keyword now, and now if I run this, then I am getting here error. So case expressions must be constant. So case expressions must be constant expressions. So whatever we write here, these expressions for case should all be constants. They cannot be variables. So the value can change at runtime. So the value now initially is here 6, but now here I have written this value of the variable, the data type here is int. But if I just make it string type and then just give here any random value, and then if I try to specify this here, then the data types as we saw earlier should match. So this here, the type of this variable a is int and this is string. So we still get an error that cannot convert from string to int. So we should always specify our constants and variables are not allowed. So I want to check 6. So if I just write 6 here and I run this, then we are getting a proper output. So the value of case expressions must always be true. So every case label should be compile time constant. So compile time constant, these values, the value 2 here is hard coded by me. So here this value, for this case, this cannot be changed at runtime. But if this variable at any point here it is initialized for the value here high, and let's suppose this is an int variable now. Suppose this is an int variable and here I have written b, but it is not confirmed that the value of this variable b will always remain 4. It will change. It might also change. So here if I just do, if I give just any random value, then this is valid. So the value here can change as well as the data type here also can change. So this can cause runtime error. So to avoid that here, these should be compile time constants. So the variable written here, its value will change. But the 6 and the 2 which I have written here, these cannot be changed at runtime. These are compile time constants. So when the code is compiled, these values are constant, and at runtime, these values won't change. So these are compile time constants. So these should be compile time constants, else we will get error. So this is the same. So this is the same example here. This is 10 and here we are giving. So we are getting an error here because we are giving a variable. So these should be constant. So if I just directly make it 20 here, then this would work and a program would just run fine. So now here is one more example. If we declare y as final, then we won't get any compile time error. So let's understand what this means. So this variable b here, this is variable, but if I make this as final variable, and now when I run this by giving here this variable b, so now when I run this, I'm getting 2 as our output. That is, I'm not getting any error. So if I just change this value to 6 here and I run this, so this value here is 4, value of variable b is 4. When I change this, so this case is executed. So what happens here is the variable b is now final. The final variable means its value cannot be changed. So once I have assigned it the value 4, it is a constant value now, it cannot be changed. So if I just write here b equal to 5 and I try to change this value, then if I try to run this, then I am getting here error. So final local variable, this final local variable cannot be assigned. It must be blank or compound assignment. So it is the same that this variable is final, so it cannot be assigned any other value. So if I just remove this and run my program, then it works perfectly fine. So if we are declaring variables as final, then these are treated constant at compile time. So final variables and these values here, these which mean the same. So we are not getting any error here. So this is the same example here. So here just there is a mistake that this isn't declared final. So just write the final keyword before the variable declaration of this variable y. So keep a note of it. Then the third case, every case label should be within the range of the switch argument type. So we have seen that it should be of the same data type, but also it should be within the range of the switch argument type. So the argument for switch here is this variable a, and the value of this variable is 4, and the type of this variable is int. So the values, the case values, whichever I write here, this 2 and this 7, so whatever values I write here should be inside the range of this int. So we have seen that int has a big range, but if I just make it byte, and now when I am running this, here I just make this 4. When I'm running this I'm getting high as my output because the value of the variable a here is 4, and for value 4 we have written a case here. So this is printing high as our output. But now suppose the range of byte is from negative 128 to positive 127. So here if I just write the value 130, which is outside the range of byte, and I try to run this, then we are getting an error that is cannot convert from int to byte, because this will then go to int type. This is out of range of the byte data type. This value 130, 130 is not a valid byte value, so we are getting this error. So the case label, so this here, this 2 and this 130 is case label. These are called as case labels. So the case label should be within the range of the switch argument type. So the switch argument type here is this A. The type of this A here is byte in our case. So if I just change this to any valid byte value and then I run my program, then I won't get any error. Here we are simply getting our output. So this is the same example here. This is of type byte, and then this is valid. This value is also valid, but the value 1000 is not valid. So we'll get error, possible loss of precision, that is required int, and we are given here byte. Now let's move on. Then the fourth use case is duplicate case labels are not allowed. So duplicate case labels. So here this case is for the value 2, then this case is for value 4. Then now again if I write here for case 2, here 2 again, let's suppose I want to do this, and then this will break, and when I try to run this, then I am getting error here, duplicate case, duplicate case. So the cases are duplicated here, so we should not repeat the values. So since this case for the value 2 is repeated, we are getting a compile time error. So the value of these cases should not be repeated. Here we have the case for the value 97. So here, since this is written 2 times here, this and these are 2 times, so we will get compile time error here. So duplicate case labels are not allowed. So this is a summary of all the use cases we just saw. So this, it should be compile time constant, the case label, then expression also allowed, but expression should be compile time constant. So what this means is here I can write, so let me just make it 2, and then here I can write 1 plus 5. So if I write this and I run my program, then I won't get any error, because this 1 plus 5 results to the value 6, and the 6 here would be constant because these values are constant. So 5 is a constant and 1 is a constant, so this addition would result in 6, and there is no chance or no way of changing this. So if I just make this 6 here and then run my program, then I'm getting this output 2 again. So this case is being executed, and this 2 again which is written here. So even if I just change this to 6 here and run this, then I'll get 6 as my output here, because these are constants. So even we have written this addition expression here, the values here are constant, so the resultant value will also be constant. So you won't get any error. Then value should be within the range of the switch argument type. So we saw this. Then duplicate case labels are not allowed. Now fall through in switch. So within switch statements, if any case is matched, from that case onwards, all statements will be executed until end of switch or break. So this is called fall through inside switch. So I have just explained it earlier. So just a recap now. So here, if this break is not written, so whenever this case is encountered, matching case is encountered, all of the following cases will be executed until the end is reached. So until it reaches the last statement here, this end, or a break is encountered. So if I just remove these two break statements, all of the break statements, and I run this, and the value of this variable a is now 2. So ideally we should just see this word 2 printed, but when I run this, we are getting all of the print statements executed, because all of these statements will be executed. and these case statements will simply be ignored, and whatever statements are there here will be executed. So this is called fall through in switch, and the use of this is if you want to have some common action for all of the cases executed. So suppose if here we executed this case and then we want some operation to be or something to be done that is common to all cases, that should be done after any of the case is executed. So in this special scenario, if that is a requirement, then this fall through is useful. Or if we have that, if the value is a certain value and after that all of the cases should be executed, so at that times we can use this fall through. So just know this concept, and now let's move on. So the main advantage of using fall through inside a switch is we can define common actions for multiple cases. So just as I explained, if you want some default or some common action for all of the cases after a particular case is executed, then we can have fall through inside switch. And now the default case in Java, so we just saw that. So within the switch we can take default only once. So this is also an important point, that since case labels are not repeated, similarly default should not also be repeated. So here just d1, and then if I just try to write another default here, just print d2, and then now if I try to run this, then I'm getting error. The default case is already defined. So the default case is already defined. So I'm getting this error. So default should always be written once. This is true for all. So this case labels here and this default, these should always be written once only and not multiple times. And if no other statements are matched, then only default case will be executed. So if none of the statements or none of the cases are matched, then only default is executed. Default won't be executed in any other case. And then within the switch we can take the default anywhere, but it is convention to take the default as last case. So I even explained this. So we can take default anywhere, but it is convention and a good programming practice to take default as the last case. So that was all about switch case.